Okay, this is a video documentary of my feeble attempts to recreate the Cavendish gravity experiment. So, as you can see, I did this last year. And so what I've got here is it's a double wall cardboard box inside another double wall cardboard box. The flaps are closed, but there's a little hole cut where the flaps all intersect in the middle, and there's actually a fish line. That's a clear nylon monofilament fish line hanging right through here. The camera's not picking it up, but there's a little brass hook here soldered in, and the fish line hangs this copper pipe, which is like 10 inches long maybe. This brass wire that forms the hook for the fish line also hangs into this can of water to keep it electrostatically grounded to the same electrical potential as the big weights. So as you can see, we've got this beam. We've got two little lead weights. I think they were around a pound each, suspended on this fish line, free to rotate. And then there's two larger weights, each about 12 pounds roughly, 10 or 12 pounds, sitting on this stainless steel plate here, which is on a roller bearing Lazy Susan, so the whole thing can rotate underneath these big weights, and this plate and the can can all rotate underneath. And so then here's a C-clamp clamped onto this metal plate, and then I've got some paracord string through some holes in the box so I can pull the string back and forth. It goes clear through, and so I can actually rotate this plate back and forth underneath here. So what I was checking for was an attraction between the fixed weights and the swinging weights. Now this is actually the culmination of, several weeks of effort, because at first I started out in the open, and the drafts, just the air movement, was driving it crazy, and all sorts of stuff. So I kept refining it until I got some results. And this still wasn't perfect, because when I would move the string back and forth in here for a couple times, then it would start building up a static electric charge from rubbing on the cardboard, and then that would, since this was all electrically bonded together, then that would cause opposite charges to attract and equal charges to repel. So then these weights would actually be repelled by each other. So I ultimately had to put in hardware cloth around here. I'll show that later, but at this point I didn't have that. So you can see, I'm going to go ahead and play this, and at first, before the static electricity builds up, it's working. Now this is playing 60 times speed, so each second right here is actually a minute, and so this is actually really, really slow. This is 60 times speed. But you can see when I change the position of the big weights, then the little weights would follow as if they were attracted. But you can see it's starting to get a little funny here, probably partly due to static electric buildup and part due to the torsion of the nylon fishing string, which was about 10 feet long, hanging from the ceiling. Now, you might also be saying, well, the rotation of this can is rotating the water, and that's rotating the wire, and obviously that's not happening, because this water would have to be turning for some time in order to keep this turning, and it's not. But so later I show why that's not happening. You can see it's now the static electric is pulling it towards that string there probably, and the torsion of the fish line is probably counteracting it a bit. Although you notice, as the static electric field slowly dissipates, this is getting pulled back towards the weight. Okay, that's the end of that clip. Now I'm going to go on to the next clip where I show that the rotation of these small weights is not always even in the same direction that I rotate these. So I'm going to rotate the big weights one way, and these small weights will begin moving in the opposite direction towards the big weights. So let me play this. See, I rotated these big weights this way. That would have got the water rotating this way. But the little weights rotated the other way in order to go towards this. Let me back it up. I'm going to pause it and back it up. So what I had done is I had let this beam finally settle to where it was at its natural resting state for the torsion on the fish line, and then I put these weights back in here so that it was equidistant roughly between them, so it wasn't being pulled one way or the other, or it was being pulled both ways equally, which allowed me to then turn the big weights one way. You see, they just came this way, which would have gotten the water rotating this way, and yet the small weights still go the other way to go towards the larger weights. Now later I went on to do several experiments. I used a compass and magnets to show that this was not responding to magnetism, and that these lead blocks were not magnetized because they did not affect the compass at all. And I also actually went on to use a high voltage generator to induce strong static charges, which would repel the small weights from the large weights. So actually when I put a high voltage on the whole apparatus, these would swing away and be repelled. And then I also took out the can and put opposite charges with the negative on the outer blocks and positive on the inner blocks or whatever, and then that caused a very, very strong attraction, much stronger than this other non-electric attraction. So I ruled out magnetism, static electricity, and air currents by having it in this box. Okay, let's go on to the next one. Now, so here is later I can get this playing, I guess. I actually lined the inside of the box with hardware cloth, which is like a metal mesh, and I connected it electrically to the Lazy Susan and everything. So now it was all static shielded, and that helped the static problem a lot. Unfortunately, by that point I'd been working on it for weeks, and I was tired of it, and I didn't get much more video. I did set up here, so I've got a little laser pointer right here pointing straight over to here, and then I put a little piece of fish line sticking up on the corners or on the ends here, so when they cross the beam you can see a flash of light. I was going to try to time it and calculate the period of the swing basically, but like the fish line bias was always giving me grief. So, but this I'm just showing you to demonstrate how I ultimately ended up shielding it from static electricity. So that's about it.